Hey YouTube, Jake Kilroy here, back in the shop, working on the Alzmetall drill press depth stop. This week, this episode at least, we're working on the stop block. It's the actual block that will clamp to the rod and provide our stop functionality. Got a drawing here, so in just a second we're going to go to the computer and take a look at the CAD, and so you can see how this is going to fit up. And then we're going to discuss making it. So let's go to the computer and check out the CAD right now.
Alright guys, here we are. This is the drill stop as we left off, with the modified stop rod and the groove cut for the scale. And the next piece part that has to happen here is the stop block. And this is what the stop block looks like. You see a hole here for the clamping screw. It'll go through here to clamp the stop block to the rod, and then at some point over here there will be the vertical screw for the power feed kick out. And then this side of the block will also reach over and interact with the automatic switches for the tapping cycle. So this is the part. So let's open that up. So the whole piece is 2.412 wide here, an inch tall, inch thick, and then has this detail out of the center. And so let's go take a look at the part.
All right, so square hole. I get lots of comments. People, oh, can't wait to see the square hole broaching, can't wait to see this, can't wait to see that. 2 words: Waterjet. No, I don't have a Waterjet. I think you might know that if I did. But they exist and they are for hire, and I have a vendor that I use on a regular basis that has the Waterjet, and he has Waterjet cut these parts out of some 1-inch plate for me. So let me get the part and let's check it out. Alright, here we are. There you go. The obviously not a big job or a big part, but check it out. I drew the dimensions of these surfaces in here a little small so that I could go after it with a file to fit it, which this other one, he cut me 2. I have filed, hand fit to the stop rod to get a snug fit. So people are going to be going, oh, you cheat, you cheat, you cheated. You should have been in there with a file for, how does Tom Lipton count them? By albums? You should have been 2 or 3 albums in. I have a 7-year-old and a 10-year-old. And lots of work. So I may not get to spend as much time in the shop as I'd like to. A lot of people have these issues, limited time availability, especially to work on, I guess you would say, especially work on YouTube projects, right, other than paying projects. So I chose to go about it this route. Of course, I have a good relationship with this vendor. I can just send him the DXF file and he can pop this thing out. But what I thought we'd do right now, since I have a drawing and I have the part, let's see how good he did with the cutout versus the part. So let me get Helen to say it. We'll caliperize it here. 0, clean them off here. So the total width of the part is supposed to be 2 0.412 inches. Let's see what we got here. Um, 2.411. 2.411. It's pretty good. 1 thou on that exterior surface there. The dimension across here, across the top, is 1 1/4. Let's see what we got here. 1.236. The width of the square hole was 520. Let's see, let's measure the one that I haven't filed on. And I'm at 520 exactly. And the height of the front to back dimension on the square hole was 505, or 515, excuse me. And I am at 512. I have no doubt that when he cut this slot here, this long slot, the part closed up a little bit. Anyway, that's how I did it. So I have file fit the interior of this one here to the stop block. I've done no other work on the exterior. It comes just the way it does off the Waterjet. So let's go over the machine and kind of trial fit this up. All right, so here's our stop block. And got a nice fit here without a lot of wiggle. It does intersect with the switch, and you'll note in my drawing that I have some slopes on here to ease this transition so I don't just break the switch, the stop block. So the clamp bolt is going to come right out the face here and is going to clamp this on. If we take a little clamp and just simulate. There you go. So that's how the stop block will work here. So our next operation obviously is to drill and tap whatever other operations we have to do to mount the stop rod. So let's go to the mill and get that done. Alright, I got my part in the vise here. With the side I'm drilling through up. I'm flush with this edge, and I'm going to use the old incremental and absolute feature to re-zero my DRO after Alright, that's 0 on the X. 0 on the Y, and that little end mill right there lines us up right with the corner. So I'm going to switch back over to incremental, raise 0 X, raise 0 Y, so I'm good to go. Let's get our tooling changed out and we'll start punching some holes. Alright, I got my drill chuck mounted here. First thing we're going to do is spot. And our dimensions over are 136 from this edge and 1/2 inch from the back edge. That's 136. We're going to lock the X. And then we're 1/2 inch from the back edge. There, 1/2 inch. So let's spot, and then we're going to drill in with a Q size drill. I have to drop the knee down here. A little bit more. Whoop. All right, we're gonna go take it nice and easy. We're gonna This top section is going to be drilled out to 13/32. That's passage hole for the clamping screw. Just through the face here. There we go. All right, the tap size and the passage hole are drilled here. So let's go back and take a look at the clamping screw. All right, we got the block and the vise here, and I've just eyeballed it over at the angle necessary to cut the little slope for the tapping cycle switch. It's not really a critical dimension, just as long as we have clearance. We've got a 4-flute carbide end mill here in the machine, and we are going to fire it up and make a few passes here and see what we got. All right, now that I got a little cut there, I can compare my cut to my scribe line and adjust just a little bit. That should do it. We'll go mock it up. Alright, so the passage hole and the threaded hole for the cat. Passage hole is drilled. Clamping screw. We need to build a clamping screw now. So fast forward a little bit. I've already built most of it, so we're going to go to that video now. So the hold down clamping screw, or the clamping screw for the stop block, it's just straightforward turning exercise with 6 different diameters, and the ends threaded for 3/8 by 24 thread. This is straightforward stuff, but the part that I do want to go over is I use my tailstock die holder to thread the 3/8 by 24 thread, and I'm going to show you a little video of that process in action. Cut a 3/8 by 24 thread on here. What we're going to use is a tailstock die holder. Here you go. This is a 3/8 24 die, and on most quality round dies you have these opposed set screws, right? And in this die holder you have two. This is the actual piece that holds the die, then there's another piece that goes in the tailstock. This piece is made by APT, which is I guess a renaming of the old Alvord Polk. So anyway, you loosen the set screws up. This one takes 1.5 inch die. You line those set screw locations up with the 2 spots on the die, and there you go. Then it's got a pin here that puts it on the tailstock component, which I'm going to slide up into place. Let's move down a little bit here. Let's see if you can see that. Yeah, you can see this okay. So there's a Morse Taper 3 shank that goes into the tailstock, and this slides on the tailstock on the tailstock insert and is held stationary by the pin. And then, so what you can do this under power or by hand. So you get the piece in place, guide this up. Usually what I'll do is just run this up with the tailstock until it engages, and then I'll stop, and then the advancing screw will just pull this away. Let me get that call. Alright, there we go. Beautiful 3/8 by 24 thread. We had the lathe in the second back gear range, so we were running about 25 RPM there. Just, you obviously can do it faster, but just makes it easy in case you get a unexpected happening. Just to show you, I also have they also make a 1-inch carrier and a 2-inch carrier for the same tailstock insert. So you can handle everything from 1, 1.5, 2-inch, and then you can buy a Morse Taper 4 tailstock insert, and it fits these same carriers as well. So the tailstock die holder setup's pretty neat. I've got a Morse Taper 3 insert that goes in the Revette. I've got a Morse Taper 4 insert that goes in the Pacemaker, and all of those die holders will work on either tailstock insert, so they're interchangeable. They're made by APT, they're very reasonable, and they're available from McMaster Car, and I will put the part numbers down below for those setups. It's very useful. So now we're going to cross drill the end of the clamping screw for the timing bar that's going to go in here. So let's get to it. Okay, guys and gals, here we go. I made a off screen. I made a Tommy bar here out of just a piece of 1/4-inch drill rod, and I threaded in each end and put a acorn nut. Well, it had these little stainless steel acorn nuts. I made it a little long because, you know, you need all the help you can get sometimes, but I might shorten it up a little bit, maybe take an inch off of it. It certainly works. So if you watch here, watch the slope. Here's the switch. I'll tell you what I'll do. We will demo here. Let's take this drill bit out. Alrighty, put it in, make sure it's in tap mode. So we're in tapping cycle mode. You lower the tap down, it engages the work. Reverses, comes back up to the top. Reverses. Let's get a better angle. There you go. So that is where we were going for there, and then it also works as a positive stop here. The only thing left to do is to put the screw through here that will engage the power feed cutoff, so we'll do that next. And then I think I want to try to calculate the offset between the bottom of the block, or the top of the block, and the point at which the tapping cycle disengages or reverses, so that I can have that piece of information as knowledge, so when I use the scale I can set it properly. So there we go. The depth stop is functional now, at least say 75% of the way. So there we go. That pretty much completes the Alzmetall Depth Stop. A little bit work left to do, but not a terrible amount. We're going to have a Feed the Monster / Shop ADHD here coming up soon, and so look for that. And then as soon as this is done, we have another project coming up, so I want to show you a little teaser. So for those of you that remember the Pacemaker, here's the gear out of the Pacemaker. The area where the missing tooth was has now been welded up. I took this down to a friend of mine that does TIG welding for me under contract, and they ground out the bottom a little bit where the missing tooth was, and then just welded this up full. And then we are going to get this set up in the big Kearney Trekker, and we're going to cut those two teeth back. We'll just use the existing teeth as the index, and then we will cut these two teeth. We'll also have to turn it. It's oversized by about 1/8 of an inch on the diameter. I guess not quite. So there we go. We'll be back on the Pacemaker soon, and I know everybody has been waiting for that. This is how I decided to go with the gear repair, and keep an eye out. Be safe in the shop, and I'll be back with you soon.